Today I will compare two different object-oriented programming and their compilation process. So whenever we are dealing with some object-oriented programming or whenever we are dealing with some programming language, the first thing you have to keep in mind that how to execute that program means what are the internal configuration that the program will maintain while compilation and execution. So now first let's talk about C++ programming. Whenever we are learning some programming language means we have to write some source code, say some particular name of the file, and then we have to give the extension. If we are learning C++ programming, then the extension will be CPP. If it is a Java source code, then it will be .java extension. So using the extension, we can understand what is the source code, means what is the nature of the source code. So first I will talk about the C++ programming and how it is compiled. But before starting this, what is the actual instructions that contain in the source code of the C++ file? One common thing we will have, that is each and every C or C++ file will have hash include directives. So in case of C, we will use hash include stdio.h. However, in case of C++, we will use iostream.h. This is a header file and rest of the instructions will be written according to the source code type. So whenever we will write any source code in C programming, then the compilation process will be entirely different. So now today our topic of discussion is C++ source code compilation. So basically C++ compilation involves three steps. The first step is known as pre-processing. So what is the meaning of pre-processing? See, the preprocessor takes the C++ source code. This file is taken by the C processor and it basically deals with the hash include directives. So the output of this step means whenever the file is pre-processed, so whenever the source code is pre-processed, so the output of this code will be a particular file that does not contain this directive. So the point is pre-processing means we are going to exclude this hash include directives and then rest of the part will remain in the source code. So this is the pre-processing step. Then after pre-processing, then we will compile the code. So the second step is compilation. So we know that the compilation takes the pre-processed output and produces an object file. So you have to remember one point, what C++ compiler will take. So for a C++ compiler, the input is your pre-processed file, means a file without hash include directives. And as an output, the compiler will produce object file. Now how could you understand that it is an object file? You will see that extension of the object file will be .o, means name will remain the same but the extension of the object file will be .o. And the third step is known as linking. Linking means there will be one linker and this linker takes the object file. So this object file will be fed into the linker that is produced by the C++ compiler, and then it will produce one executable file which is also known as exe file. So if I tell you that what are the basic compilation process for C++ source code, it is a very simple step that C++ source code will follow this three basic steps. Preprocessing for excluding the hash include directives, compilation for generating the object file by considering the preprocessed file, and then the third step is linking. So linker is responsible for generating the executable file. Means by executing this file we will able to see the output. But this is not the actual execution process of C++ programming. So I will give you more details about the source code compilation process for C++. So these are the basic three steps. Now look into this compilation and execution process in more details. So whenever a particular C++ source code is written by the programmer, it should be saved with the extension .cpp. So this is the first step. Afterwards, as I have explained, I will find a processor. So the processor does the pre-processing step. So we will have C++ pre-processor. Now, what is the responsibility of the C++ processor? I have explained that it will deal with the hash include directives, means it will deal with the hash include header files. So the responsibility of the preprocessor is to exclude this header file. Afterwards, there will be one temporary file that will be created. So my point here is, in the previous step I was explained that after pre-processing the source code, we will get a specific file which does not contain the hash include header file. And here I am adding one more point, that this file is a temporary file. That is, this temporary file, which is also known as expanded source code file. So now there will be one question in your exam. What do you mean by expanded source code? So whenever a particular programming code in C++ is pre-processed by the preprocessor, then whichever temporary file is created, that temporary file is known as expanded source file. And the property of this expanded source file is this source file does not contain any header file. Now, afterwards, we will use the compiler so that our temporary source file can be compiled. So after compilation, we will actually get a particular program with .s extension. So initially our program, means the source code or the set of instruction, was having .cpp extension. But after compilation, whatever we are getting, it is having .s extension. Now what is this? This is known as assembler file. So now what happens, whenever compiler generates this .s extension file, then we will feed this file into the assembler, and then we will actually get the program file with .o extension. I was explaining in the previous step that compiler is responsible for generating object file with .o extension, but the actual explanation is compiler will take this temporary file as an input and generate .s file first, and this .s file will be fed into the assembler as an input, and this assembler will in turns produce output of the object file. Now here the question is, what is an assembler? So an assembler is a program that converts assembly language into machine code. So the responsibility of the assembler is to convert. What it will convert? It will basically convert one assembly language code to machine code. This is the main responsibility. Means it will take some basic command and operation from the assembly code and convert them to the binary code that can be recognized by a specific processor of a machine. Now you can ask me one question. So what is the difference between this assembler and compiler? I can tell you that assembler are similar to the compilers in that they will produce some executable code. However, assemblers are more simplistic since they convert the low level code or assembly level code into the machine code. So whenever you are dealing with microprocessor codes, so they are basically low level codes. These are the assembly language or assembly level code. So whatever may be the situation, you have to remember one point. Compiler does not create the .o or object file directly. So we have one assembler in between that will take this .s file as an input and produces object file. Afterwards, we have to use one linker, and this linker is responsible for generating the executable file. But this linker needs support. So basically this linker needs support of some library functions. So whichever library functions are available for C++ language, assembler will take the help of those library functions, and it will take the object file as an input, and all together the linker will produce the final executable file. So I have explained that we have three basic steps for C++ source code compilation. One is pre-processing, second one is compilation, and third one is linking. However, there are some internal components present that we have to understand the entire process or entire compilation process of C++ programming. So now I will discuss the compilation process of another programming language, which is an object-oriented programming language that is known as Java. So as I have explained before, whenever we write any source code, the extension of the source code depends on the programming language. So since I am writing source code on Java, so name will be say anything, and then the extension will be .java. But here I want to tell you one point. In Java programming language, what happens? Inside the source code, we have to write some class. And you have to remember one point, the basic difference. That is, in case of C programming, we can give any file name as per our choice. But in Java, there is one constraint. Constraint means there is some rule. What is that rule? In the Java programming, the name of your main class should be the name of the file. So what is the definition of the main class? I will tell you later on. But right now you will understand there will be one class in the Java file, and within that class we will have the main function. So whichever class contains the main function in Java, whatever may be the class name, the same name should be given as the Java file name. This is the important rule you have to remember. And extension should be .java. This is the first point. So you cannot give any name according to your choice for Java source code compilation. So after you have written the source code, the next step is you have to compile the source code. Now I have one more point to discuss here. See, in case of C programming, you may find many type of compiler. In C programming, if you are working on Windows machine, then you can use Turbo C++, Dev C++. But if you are working on Linux machine, then you have to use GCC compiler. So my point is, if you are compiling any C programming source code, then the compiler, which compiler you should use, sometimes it depends on operating system, and sometimes it depends on the choice, because if you are working on Windows machine solely, then you can use any one of them. Nowadays we also have code blocks in Windows. So since it is a newest compiler based ID, we will use that. But in case of Java, you have to remember one point. Universally, there will be only one compiler for Java, and that compiler name is Javac. So, irrespective of the operating system type, irrespective of the machine type, there will be universally only one compiler for Java code, and that is known as Javac compiler. So whenever you compile your Java code in Javac compiler, so this compiler is responsible for generating bytecode. So this is the newest thing. If you remember in C++, the compiler will first generate .s file. Afterwards, assembler will generate .o file, object file. So basically, compiler in C++ compilation process will generate object file. However, in Java, the compiler is responsible for generating bytecode. Now, how you can identify this bytecode? Remember one point. If the name of your source code is a.java, then your bytecode name will be a.class. So here we are clear with one point that the extension of the bytecode is .class. But name of the file will always remain the same. So here I can conclude that the responsibility of the Java C compiler is to take the source code as an input, and it will generate bytecode as an output. And the extension of the bytecode is .class. So this is the first step. But there is another point you have to remember. You can say that this bytecode can also be considered as class file. This bytecode is also known as class file. So after this step, now we have to proceed so that we could execute this code. So after this class file is generated, the next step is you have to use one class loader. Now the point is, what is this class loader? You can say that this class loader is a kind of subsystem of a JVM. Now what is this JVM? Now I will tell you one more point. That if you want to visualize the compilation process of Java, there will be one source code, and source code will be compiled by a compiler, and then it will generate one bytecode, right? Now you have to visualize one more thing. After generating the bytecode, we have to use one more component which is known as Java Virtual Machine. So after generating bytecode, we have to use some of the subsystems inside the JVM. So basically, when I am talking about a class loader, you have to remember one point, that it is one of the component or one of the subsystem of the Java virtual machine. So first this class file will come to the class loader, and after functionality of the class loader, then we have to move to the next step, that is known as bytecode verifier. So remember one point, after generation of the bytecode, we have to move on to the JVM, and we have to pass our bytecode by several subcomponents inside the JVM. So the first component of the JVM is class loader, and the second component is known as bytecode verifier. And then we have to use one interpreter. This is another subcomponent of JVM. And then we will have some runtime environment, and afterwards it will interact with the hardware, and the main intention of the JVM is to generate a particular executable file or the machine code. So after dealing with all these steps, the JVM will provide you a particular executable file. So this process is rather very difficult to understand, but in the simpler way, I can give you one idea. But before that, just make a recap that what Java is doing actually. So in case of Java, I can explain this in a simpler manner that you have a source code with .java extension, and whichever source code you are having, you have to pass this source code into the Java compiler, and Java compiler will generate dot class file, which is also known as bytecode, and afterwards we have to provide this bytecode, or we have to hand over this bytecode into the JVM, Java Virtual Machine, and Java Virtual Machine will have some sub components, and the more promising sub components are class loaders, then bytecode verifier, and we have just in time compiler. So these are the basic components we have. I will explain each one of them. So here my point is, so once the class file, dot class file is loaded into the JVM, then the JVM is responsible for generating the machine code. And what is this machine code is all about? You can say it is a binary file which comprises of 01101. Now, what is the basic difference I was talking about? In case of C++, you just try to understand, we have to deal with the assembler and linker. But in Java code compilation, there is no question of assembler and linker. We just have a Java C compiler and then we have a JVM. Just a simple mechanism. So my point is, the ultimate aim of any source program is to generate a machine code. But here Java has the simpler step. It is just using two components, one compiler and one JVM, Java Virtual Machine. However, C++ has so many steps. So this is the basic compilation difference between two object-oriented programming. This is a dot class file which is also known as bytecode, right? So what is the importance of the bytecode? If anybody asks you what is the definition of this bytecode, see, from this diagram, I can derive the definition of this bytecode. First point about the bytecode, we know that the extension of the bytecode is dot class. Number two point that I can explain, this bytecode is generated by the Java C compiler. And also the third point is very, very important. This bytecode is an intermediate code. Intermediate code means it is generated in between the two. But I want to explain one more thing. This bytecode is a highly optimized code. Means whenever I open a bytecode for you, you will not be able to understand anything. So this bytecode is meant for the machine. A machine only could understand this bytecode. That's it. So the property of the bytecode is it is highly optimized and intermediate in nature. But now the next question that come in your mind, why I am concerned about this bytecode? Now the point is, this is the beauty of Java. In case of Java programming, if you have the bytecode, means if you are copying this bytecode in your pen drive and executing in your own machine without having the source code, then also you will get the output. Means for C programming, what happens, each time you have to copy the source code. See, you are writing one C programming with .c extension in a turbo C++, right? Now you are copying this source file at your home and you are trying to compile and execute this same file on your own machine. What happens in case of C programming, if the operating system changes or machine configuration changes, then you have to modify the source code. I'm giving you one example. Sometimes in dev C++, you cannot write getch or you cannot write void main. In code blocks, you have to write int main. In some compiler, you have to write void main. So each time the source code differs when your compiler differs. But Since for Java we have only one compiler, so there is no question of changing the source code. So here my point is, whenever you have executed your Java code using this process, then if you want to execute the same program at different machine configuration, what you have to do, you just copy the bytecode and just execute the Java file. No need to copy the source code, no need to compile the code again. So this bytecode is something which can be executed on any machine, on any operating system without changing your source code. So this bytecode is responsible for making Java platform independent. So what is the meaning of platform in computer science? Platform means basically the operating system or the machine configuration. So Java is platform independent. Why it is platform independent? Because Java is having bytecode. Who is responsible for generating this bytecode? We know that Java compiler. Java is responsible for generating this bytecode. And whenever we have the bytecode, then the Java code can be executed on any machine configuration, that is on any platform, without having any change. So for that reason Java is platform independent. So my point is, the bytecode concept is very important because this is the thing that will make Java code platform independent. However, C code is not platform independent.